Hello everyone, this is Aditya, and today we will see why there are infinite real numbers between 0 and 1. So this was asked me in the comment section by someone from 10th grade. Of course the question was different, but the gist was this. And I need to clarify one thing. When we refer number, then we generally mean natural numbers, right? So the question that was asked was, if I say in simple words, are there infinite numbers between 0 and 1? So that was the question which was asked that time. So in that case, if you asked me why, or maybe are there infinite numbers between 0 and 1, so in that case I would have answered no, because when we say number, then we generally refer to natural number. So there's no natural number 0 and 1, right? But of course, in day-to-day life, we don't care much about this term, but it is really, really important, right? So the question should have been, are there or why there are infinite real numbers between 0 and 1? So I hope that the question is clear now. So let's start with the proof, and I will give the proof using two methods. The first one, which will be very much understandable by 10th grade easily, and the second one using a sequence, which is also easy, but still it is not that much into the hands of a 10th grader. Okay, that is why I will use two methods. So now let's start with the video, but please, before that, please do like and subscribe my channel, and please support this video, and please support my channel. And now let's start with the video. So let's start with the method one. So method one is basically using some examples, right? What do I mean by examples? Well, this is your first number and this is your second number, right? Number or a whole number. This is also a whole number or natural number, whatever you want to say. Okay. So you need to find, suppose, a number in between of them. Well, so how you will find 0 plus 1 by 2, which is 1 by 2, right? Fine. So this is your first number. Okay. Now 0 plus 1 by 2 by 2. This is a number between 0 and 1 by 2, which still lies between 0 and 1. Correct? Okay. So you have 1 upon 4. And 0 plus 1 upon 4 by 2 is still 1 upon 8, and so on. So you observe a pattern. This is 1 upon 2 to the power 1, 1 upon 2 square, 1 upon 2 cube, till 1 upon 2 to the power n, right? This is correct? Okay. So notice that this is 1 upon 8, 1 upon 4, 1 upon 2, and this is 1, right? Correct? Fine. So now the question was that they stated me that there are many numbers, many real numbers between these two limits. Still, we know all the numbers. How? Well, that's a question to understand properly, to imagine properly. Well, to some extent, it is somewhat acceptable, but not always. How? Let's see. Suppose if I say 1, 2, suppose how many numbers are between 1 and 5, right? So you will say 2, 3, 4. So we know all the numbers between 1 and 5, right? But if I say how many numbers are between 1 and from suppose 1, 2, 3 till infinity, means how many numbers are there in set of natural numbers? Well, we can think of some very large numbers, suppose 9, 9, 9, 9, 9, 9, and so on till 9, 9. Suppose this is 100 times 9, okay? You can still add 1 to it and you will get a number greater than this, right? So there is no limit to which you can think of a number, right? Because it goes till infinity. Now, what is infinity? First of all, you need to understand that. Well, infinity is basically not a number. It is a concept which is used to tell our limitations, that we can't tell that this is the stopping point of a particular set of natural number, maybe, or whole number, or real number. We just use infinity to limit ourselves, that we are not capable of going to that level. So of course, when you say that there are infinite terms over here, it means you can't count every term over there. There are infinite terms, there are endless terms over there. So that is what we mean when we say that there are infinite terms between 0 and 1. It is just because we can't count that how many numbers are there, because notice that here n belongs to natural number, because n can take value from 1 2 till infinity, right? Which means that if n is not defined, I mean n is defined as a set of natural number, but the last value, the end value of n is not defined, so we can't define this whole set of numbers. What is that? 1 upon 2, 1 upon 4 till 1 upon 2 to the power n, right? And here n belongs to natural number, right? So this will go like this, so on and so forth, like this. You don't need to use this, which means that this is an infinite set. And what is an infinite set? The set in which the elements can't be counted, right? So you can think of a real number that you know all the real numbers between them. You will still find another real number between them that you don't know that it existed, right? You can imagine just that, yes, I founded these many real numbers. There are still many going through, right? Because you don't have any ending point to it, right? And that is the basic concept of infinity. I'm not going into much detail because it is something which I need to explain to a 10th grader, but in the second method I will explain it in great detail, right? But for now you need to just understand that here infinity is basically not a number, it is a concept to tell our limits. It is just to tell that there are endless terms in it which you can't tell how many are there. You can't tell how many terms are there. So of course, when you suppose you write 100 trillion terms, you can still find another 101 trillion term over there, and so on and so forth, like this. So it is not like that you know every number. You don't know every number because it is limitless, of course. Basic meaning, what I mean to say. It is something very basic which I'm telling. Okay, and if I go in much detail, then there are many other things which we can discuss, limits and all. We don't discuss it. But I know that now your question is clear. Okay. If it is not, you can comment. Okay. I will see to it. Now let's see the second method. Now in the second method, we are going to see something in a general way. So suppose we define AI, right, which is greater than 1, right? It is just a number. And now AI belongs to real number, right? Okay, fine. So now what you are going to do is that you will do like this: 0 plus 1 by AI. It is 1 upon AI, right? Now notice that since AI we assumed is greater than 1, which means that 1 upon AI is less than 1. And of course, it will be greater than 0 also, right? Which means that this quantity is always lying between this, right? Okay. Now we define a sequence that um, sequence of AI, A1, A2 till AN and so on, right? In which there are infinite number of terms, or suppose for now just assume there are n terms, right? Okay. And AN, suppose suppose A1 is greater than A2 is greater than this, and AN is the least value, which means that when you take the, or do like this, it is better, right? Now when you reciprocate this, you get 1 upon A1 is greater than 1 upon A2 is greater than 1 upon AN, A3 and so on till 1 upon AN. Now notice that you can put this over here because it is valid for all AI. So you can say 0 less than 1 upon a n, less than 1 upon a n minus 1, and this still 1 upon a3, 1 upon a2, 1 upon a1, 1 upon, 1. Okay. So notice that here also you have nth terms like an minus 1 till a1, right? But notice one thing, that over here you can use the limiting case, limit n tends towards infinity of this an 1 upon an minus 1, an minus 1, 1 upon an minus 2, so until 1 upon a3, 1 upon a2, 1 upon a1 less than 1, right? So notice that this expression is still valid, and what it means is that for infinite terms of an, of ai or whatever, this term still holds. This is still true. You still have infinite number of terms between 0 and 1, infinite number of real values, right? And it is something very much fascinating, that it can be a rational value also, it can be irrational value also, it can be a not integer, because in this case yeah, of course, ai can be an integer because it is a real number, right? Okay, and greater than 1, so you can take ai as 2, 3, 4, whatever. Okay, you can take root 2, you can take root 3. As far as ai is greater than 1, you can take any value, right? And it should be belonging to real numbers, right? So it means that you have just now proved that between 0 and 1 there are infinite number of real values, right? And it is again our limitation. We don't know what infinity is. It is not a number, it is a concept to tell our limits, or it is sometimes we treat it as a very big number which we don't know what is it actually. So in that sense, this makes lots of sense. Okay, so I hope that you understood that what I mean over here, and basically this is a general method which we can use to prove that there are infinite real numbers between 0 and 1 using a sequence of this. Okay, maybe I can define it as ai as this. Okay, I hope now it is. So this is, I hope that it is clear now, and maybe you understood it. Okay, if you understood it, then please do like, subscribe my channel, and please support this video. Bye bye, take care.